Hi, my name is David Scott, and I'd like to talk to you about the project I'm trying to raise money for. So the project that I'm looking for is the fees towards a master's in cognitive and computational neuroscience. The reason I want to study this master's is because I've got this novel neuroscientific approach to systemic illnesses, particularly ME, CFS. So if I first tell you a little about myself, a little bit about myself, I've got a physics degree which I got 20 years ago. I'm a chartered physicist. I have 2/3 of a psychology degree, so I've already covered some aspects of neuroscience. And most of my career I've spent as a nuclear safety engineer. First half was more reactor engineering, so it was more to do with nuclear power stations, and the second half it was more process engineering. Process safety engineering is really to do with looking at complex processes, things moving about, looking at complex systems, trying to simplify and understand them, and then seeing how they can fail and protecting against those failures. So engineering, and particularly safety engineering, is very different from medicine and the biosciences. I want to bring my knowledge, my techniques, and my perspective to neuroscience, and I think that will be a valuable thing to do, and it will offer a unique perspective, and particularly in attempting to solve these systemic illnesses. If I tell you a little bit about these systemic illnesses, now I've actually had 3 of them. I've had IBS in my early 20s. Mid-20s I had MCS, which is multiple chemical sensitivity, which is not a recognised illness, but I was very ill. And then in my mid-30s, ME, CFS. CFS is a debilitating long-term illness, which I nearly completely recovered from. And I'm looking to start this master's next September. The symptoms are actually very similar for all of them, but gradually getting worse. IBS you normally think of as gastrointestinal, but there was also some brain fog, albeit mild, and fatigue. For MCS it was only triggered by chemicals, but mainly laundry detergents, and I was extremely unwell. It affected my sleep, either felt really tired or couldn't go to sleep. And then ME was way worse. It affected my sleep, it made me feel extremely unwell. It was less, there's this thing called post-exertional fatigue, which is where if you do too much it makes you, in my case it was more to do with concentration and stimulation, so I pretty much had to isolate myself from everything because everything was setting it off and making me feel violently ill. And it was, it covers your stomach, makes you fatigued, affects your heart. It's sort of a systemic illness. It just makes you so unwell. So I've got first-hand lived-in experience of these illnesses. That, coupled with my engineering, my scientific background, my broad multidisciplinary knowledge, I think will be of value in looking at this research area. So what is my novel approach? Well, my novel approach actually is not new. It's no new science. Really no new science. There's no being magical. There's nothing complicated or exciting, really. You say, well, why haven't they been able to solve it? Well, I think the problem is not to do with how difficult it is. The problem is with how it's been looked at. Now, in science, they say if you look at things in the wrong way, ask the wrong questions, you're going to get the wrong answer. And this is what I think has been happening with these systemic illnesses. So the problem with how it's been looked at is due to the medical approach. And there are 3 problems. The first one is to do with the fact that medicine looks for pathologies. It looks for injuries, it looks for pathogens, it looks for some biochemical malfunction. And there isn't any for ME/CFS. There's a few, some things seem slightly strange, but there's no pathology. They can't identify any pathology. Of course, not everything in medicine has a pathology. Some illnesses arise out of no pathology. I'll come on to that. The second problem relates to how medicine is structured. It's actually structured between physical and the psychological. Problem is, some illnesses cannot be reduced to either one or the other paradigm. You attempt to look at it in the purely physical, you can't solve it. Purely psychological, you can't solve it. You can only understand it if you look at it in terms of both of them, if you think about it in terms of the interface between the two. Now, that's true of everywhere. It's true of nuclear engineering. If I look at two plants separately, I will miss things. I will miss faults. I can only identify everything by looking at both plants, because some of those faults arise from the interface between those two plants. So I will never be able to understand it, never be able to solve it and identify and protect the public unless I look at both plants at the same time in terms of these interfaces. And that's exactly the same in medicine. Now, medicine already does do this for some illnesses, which again brings me on to the third one, and this is the most rage-inducing one. And that's the fact that medicine there's a hierarchy of symptoms. Medicine is prejudiced against some symptoms. Things like high temperature, high blood pressure, broken leg, things you can see, the concrete you can understand. Medicine's like, we're a science, we have to be objective, therefore we have to understand these things. And anything that is vague, fatigue, post-exertional malaise, never come across that, don't understand it, therefore it doesn't exist, go to a psychiatrist. Well, actually that isn't how they approach other illnesses, and I'll give you an example of that, and that's high blood pressure. You go to a doctor, measure your blood pressure. If it's slightly high, they might look for a pathology, but the vast majority of the case they won't find anything wrong with you. But the doctor will go, well, okay, that's normally down to lifestyle, which is psychological. It's normally due to drinking too much, smoking, not doing enough exercise, eating the wrong food. So it's a purely lifestyle thing. So in fact, what's happened is there's been a physiological response. The circulatory system, there's been a physiological response of the circulatory system, such combined with the lifestyle to the hostile environment, which has caused this high blood pressure. So in this case, this fault arises out of the interface between the psychology and lifestyle and how the body responds to that lifestyle. And that gives you high blood pressure, which isn't a pathology, of course. If you leave it long enough, then it increases your chance of getting a heart attack and a stroke or all sorts of problems. It won't necessarily definitely happen, but it's more likely to happen. So in this case, how they treat that illness is there's no pathology, and there's an interface between the psychology and the physical, yet they identify the problem. If you then take this approach they already use and apply it to ME/CFS, then what you get is you get a number of symptoms. We treat the symptoms as the problem in themselves. You'll look for a pathology, you won't find anything. The symptoms are problems in themselves. Then you might say, well, they're all sort of central nervous system related. What that suggests is you've got some physiological response in your central nervous system in response to a hostile environment. So it arises out of the interface between the psychology and the central nervous system responding to this psychology within a hostile environment. The hostile environment normally refers to trauma, drug use, or even psychiatric medicine could perhaps cause it. And it could be acute or chronic trauma. So when we talk about the interface between the psychological and the physical, in the central nervous system, it is the synapse, it's the connections between the neurons, and it's neurogenesis. Neurogenesis probably isn't very important here. So if we actually look at the synapse, if we consider how it responds to a hostile environment, to trauma or drug use, you can actually see for extreme configurations, you can actually see that the signal transmission can be disrupted. Now, this kind of synapse, it's very much a process engineering problem. It's similar to a number of engineering problems that I've seen in electronics, in hydraulics, everywhere. And using my engineering and physics judgment, I can see there could be non-linear behaviour, there could be over and under damping, frequency over and under damping, there could be over and under damping of the amplitude. Those sort of issues, non-linear behaviour, you'll get wide swings in the signal transmission, you could get zero transmission if it's over damped, you could even get resonance, you could get oscillations. So those sort of things are going to cause some sort of systemic symptom. So it's likely, I think, that those are part of the illness. The other thing, of course, is if you have suffered trauma, acute or chronic, then the brain will have adapted to that and be trying to go back to its set point. And in trying to go back, that's probably going to cause some transient symptom in itself. So what I want to do in this Masters, hopefully in the project of my Masters, I want to model this synapse and demonstrate that actually this disruption signal transmission is possible. In modelling that synapse and demonstrating that, it gives me proof of concept, so I can then move on to a PhD and research these systemic illnesses in full and hopefully solve the problem and explain this seemingly medically impossible to explain. So the benefits of that is that we will be able to understand and explain these illnesses. It's a new way of looking at the problem. So it could explain a number of unexplained illnesses. It could give more insights into ones we currently understand. It's a whole new branch of medicine waiting there to be discovered, waiting there to improve medicine. That's the first thing. The second thing, of course, is that it will explain these unexplained symptoms to these millions of people in the world who don't have their diseases treated seriously. It will tell doctors that actually there's a real physiological, biochemical issue here and you need to take this more seriously. And thirdly, of course, is it will hopefully provide some treatment ideas that will be able to be researched. So your funds will help all of that. It will go towards the fees. There'll be a little bit of spare to go towards conferences and books, etc. And then I'll get a postgraduate loan for the maintenance, really. So if you can give towards this project, then I'll be grateful. All the people with these systemic illnesses will be grateful. Thanks very much for your time.